All right. What a tricky journey this one was. Write a Java program to print the ASCII value of a given character from W3Resource websites, basic Java challenges, first 150. I went through a whole lots of reading and I did some learning in trying to solve this challenge because I tried to solve it by incorporating only certain aspects of this ASCII character set, meaning only the letters. Okay, I took character to mean letter, but the ASCII table itself includes 256 members with their own decimal code. Okay, you can see them all right here. You can just Google it and you'll find it. Now, I learned a lot doing watching videos like Starting with Alex's Unicode in Friendly Terms, which explains how the computer encodes and decodes, excuse me, encodes and decodes other character sets, and it all comes down to binary numbers, some of which are called code points, I believe, if I got that right. Nonetheless, they all are read ultimately through binary numbers, sets of bytes, sets of bytes. And that is the key right here. So when I learned that you have to um, deconstruct each letter or character, or as Alex explains it here, graphene into bytes of binary numbers, then I already had the right idea. I knew what to do, but I couldn't find the right class to do it in the Oracle website because I assumed that this was all going to be in the character class or the character set decoder class or the byte buffer or the character set encoder class. I went through all these classes. I read so much of all these classes, it's unbelievable. But it turns out that it was neither in the character set, nor in the character set, nor the character set, decoder or encoder classes, which you can see listed down here. The answer is actually in the Java string class. I'll get to it in a second. It was so funny for me because I spent hours looking over these four classes, including the character decoder class. And as you can see, all the most of the methods that they give you have to do with Unicode specifications. And Unicode, you see that? Almost all the methods from all these classes, let's just go and remove them one by one. Okay, even the character set class, whether or not it supports encoding, that is in Unicode. See this? Okay, select this one. Okay. Well, actually, that one too. But anyway, they all have to do with Unicode. So I was like, how is it that I don't find one here that has anything to do with other character sets? And what it turns out is that you have to learn about um, character transformation formats, okay, which is what this is. If you look for what does UTF-8 mean, it will tell you Unicode transformation formats, okay? This is really what you're looking for, not in order to get the answer for this challenge, okay? Because ASCII is the original character set. Unicode was added later on to include all languages around the world, okay? So the key is to know what is a Unicode transformation format, because UTF-8, UTF-16, UTF-32, and others are transformation formats, meaning ways to encode and decode characters so that you can convert them from ASCII to Unicode and Unicode to ASCII. So I had to learn about that. Well, finally, not to bore you too much, I learned that through Alex that you have to do this, convert them correct into bytes of string, and then I'll go to Java and string coding in a second. I tried to code my own, and this is the answer. First, I did it manually. Okay, now this method does not include yet the characters other than the alphabetical characters, which is why this is called an ASCII alphabet code generator. Okay, so If we run that program, that method, which is right here, look at what it does. It gives me the correct ASCII code for each letter, right? Whether it's lowercase and uppercase. Okay, but I'm not going to explain how that method works because I don't have the full ASCII characters included in that method. I could manually, like I did with this, but I'm not going to do that because it's going to be a waste of time. So I was looking for, I was forced to find, look for a tutorial on character encoding, and I came across the Java Point website, which teaches you how to. And so I had the right idea on how to do this, but I didn't have the right tools because I was looking at it in the wrong class. And as you can see right here from the beginning, the string class is the class that will give us the correct answer. As these methods that you'll see right here are from the string class. That's the get bytes method. Okay. For the get byte method, I tried the standard character sets class, but the information that you get on it is incomplete. That is, you have methods that are inherited and it gives you fields, as you can see, but it doesn't give you a method to perform conversions. You see that? So these methods that I said, excuse me, these fields that this is using are only used to deposit the character sets of a string into a string object, but you don't have methods to do anything with it. Okay, this method, assert equals methods, I don't even know what that's from. So when I saw this, I had to do some reading and figure out that the answer is actually here. The string class, which the last thing I could think of, where the answer will be, has a lot of Unicode and code points based methods, but then there's this one. Okay, get bytes method, which reading, I never paid attention to that one. I read so much about the string class and I never realized that this method encodes this string, whatever string you give it, okay, into a sequence of bytes using the given character set, meaning you tell it which character set you want to deconstruct the string into. Okay, and as Alex, studying with Alex explains here, each word or each grapheme, okay, each character here has to be deconstructed into a set of binary numbers or bytes, okay? Because it's a combination of binary numbers or bytes, meaning sets of 8 binary numbers or 8 bits, that is going to give you the code that is the Unicode or ASCII code for each particular letter or grapheme. Okay, so you need to think about it in terms of bytes, that is units of 8 binary numbers or 8 bits. That's how you have to think about it. So upon reading here, I realized that this was my answer. So you're going to see that my code is very like the code from Java Point here, and that's because it's inevitable. They are using the only tools that Java gives you. So those are the tools that I'm going to use. Java does not give you another set of tools. Okay, and this is the syntax. That is the syntax. So any code that you write using the get bytes, you have to include the throw unsupported code. Well, you have to include this whole syntax right here. Okay, you have to write it just like that. Now, I use a for loop as they do here, a special for loop that is a for each loop. I tried something else, but I wasn't getting the code to print the way that I wanted it to. So I opted for using a for each loop as well, because I was printing the whole array, and with the brackets, I didn't want to do that. So the get bytes is our answer. With the get bytes, you tell it what character set you want to break this character into bytes, right? So you're decomposing the character into a set of bytes, and it creates or it returns a byte array. which has the bytes for each particular member of whatever character you use. So let me explain that in detail. Okay, so in my code, okay, and this is, let's now comment that out, and let's bring this one up. Okay, in my code, I'll show you. Okay, we can use Z, excuse me, we can use Z to get the answer that the challenge is looking for, which is 90. You'll see it. Okay, 90 right there. Okay, or we can say Z and then lowercase z. All right, and let's see what the system is going to give you. And I'll explain this. You have 90 and then 122. So capital Z is 90, lowercase z is 122. Let's see if that's true. Let's look at the table. So lowercase z is 122. There we go. Capital Z is 90. So we got the correct outcome. And we can put anything. We can put let's add a plus sign and then, you know, whatever. And then let's see what we get here. We can put anything. We can even put space. And we'll get the correct value. So now we have 43 and 61 for the plus and the equal signs. Let's see. Plus sign 42. Here we go. 42. Oh, excuse me. Wait. Right here. 42. Oh, wait. That is 43. Oh, right here. Yeah, 43. And then the equal sign 61. Which is right here. 61. Okay. So how does that work? Let's go to the code. And here is the code. Okay, now that's here is the code. It has the syntax as you see. Okay, so I made it so that you can give it a string argument. You can feed it a string. Then I use the get bytes method from the string class right here. Okay, remember that this method returns a character, a byte array, or an array of bytes. So what it does is whatever I feed it, in this case, feed it 1, 2, 3, 4 characters. It will take each one of those characters, right? And it will actually return as if were an array of arrays. So for each character, it will give me a sequence of bytes. So there's not only one binary set of codes, not one byte, but the amount of bytes that each one of these particular characters takes in Unicode. Okay, or in this case, in ASCII code, or the Unicode equivalent for the ASCII character set, which is really what it's doing. Okay, and using the information is using the Unicode transformation format 16 because Java uses 16. Okay, it actually tells you right here. See, it is not possible to encode using UTF-8. My MacBook uses UTF-8 because you can search that out right through the get property method or from the system class. But it actually Java runs in UTF encoding right here. Okay, so this program is using the UTF-16 encoding method to tell you what is the Unicode representation for the ASCII character set, which, starting with Alex explained, is actually the same. In ASCII and Unicode, since Unicode is an extension of ASCII, they share those codes, those byte codes, meaning the set of bytes to represent one character. Okay, so then I tell it to give me the correct character, that is the bytes or the numbers right here are interpreted into their particular digits, which you will see right here. Okay, 90, 122, 43, 61, and so on. So give me the correct ASCII code. Okay, so then since it is all deposited into the array ASCII, an array of bytes, because it is an array that the get bytes method returns, then I go through each individual set of bytes and print it out. And that's how that works. So the answer is easy, but it wasn't easy for me because I had to learn that there was no other way to do it in Java. And that I thought that the answer was going to be in the standard character set or the character set class, which I read through so much for the weekend, but it turns out that the answer was in the string class. Okay, string class, you can convert any character to any other character set. Okay, which actually I should have shown you the standard character set class to show you the, oh, here. These are the standard character sets that you can convert. Every version of Java includes this, as you see right here. Okay, but there are more that my system supports, and I suppose that you can probably download them or something like that, or implement them into Java. Anyway, that is the answer for this challenge. And I learned a lot because I did a lot of reading. Something new, but this is pretty exciting. Thanks for watching.